Assalamualaikum warahmatullahi wabarakatuh. Today we will talk about law of logic. We will cover about define key term, use the concept of logical equivalence, tautology and contradiction. Next, we will use law of logic in simplifying switching network. Next, we will give example question to understanding the logic. First, we will define a key term. Preposition statement either can be true and false but not both. For example, 2 is even number. Next, we have disjunction, which means P or Q. Disjunction is true when only one of the statement is true. Next, we have conjunction, which means P and Q. Conjunction is true when both of the P and Q is true. Next, we have a tautology. Tautology is logical statement either is true for all possible cases. For example, P or negate P. This statement is always true because either P is true or P is false. It is important to help us confirm that logical expression is always valid. Next, we have contradiction. Contradiction is proposition that always false for all possible cases. For example, P and negate P. This cannot be true and false at the same time. This statement is important to help us confirm that logical expression is always false.
Okay, now I will explain about the table law of logic. First is double negation. Double negations means if a statement is negated twice, it will return to its original value. In other words, not B is the same as B. Next is De Morgan's law. This law explains how negation works with and has or. When we negate an and statement, it becomes or. This law is very useful when simplifying logical expression. After that, we have the commutative law. This law shows that the order of statement does not affect the result. For example, P or Q if the same result as Q or P. Next is the associative law. This law focuses on grouping. It means that changing the position of the bracket does not change the final result, whether we group the statement on the left or the right. Then we have the distributive law. This law is similar to expanding brackets in algebra. The statement can be distributed across n or 4. Changing is needed. Next is the idempotent law. This law means repeating the same statement does not change the result. For example, P or P is still P. Moving to the next part of the table, we have the identity law. This law shows that the statement remains the same when combined with true or false in certain way. For example, P and true is still P. Next is the dominance law. This law shows that true and false can dominate the result. P or true is always true and P and false is always false. Then we have the inverse law. This law involves a statement and its negation. A statement or its negation is always true, and a statement and its negation is always false. After that is the absorption law. This law shows that some part of a logical expression can be absorbed without changing the result, making the expression simpler. Next is implication. The implication, if P then Q, can be written as not P or Q. This makes implication easier to analyze. Lastly, we have the biconditional law. Biconditional means P if and only if Q, where both statements must imply each other.
Hi, my name is Muhammad Ashar and I will talk about switching network. In simple terms, a switching network is an arrangement of wires and switches that connect two points, which we label as terminal 1 and terminal 2. The goal is to get an electrical current from one end to the other. To do this, we treat the state of the switch as logical truth value. Closed switch T. When a switch is closed, it completes the circuit, allowing the current to flow. This represents a true value. Open switch F. When a switch is open, the path is broken and there is no current flow. This represents a false value. By using this state, we can represent complex logical expression as physical circuit. To visualize this, let's look at the three primary configurations on this slide. This diagram shows us exactly how the parallel and series network work in the real world. The single switch on diagram A, this is our basic building block. It's a direct connection between terminal 1 and terminal 2 controlled by one switch, which we will call P. In logic, this is just the statement P. There are no complications here. If P is closed, the light turns on. If P is open, it stays dark. It is the simplest representation of a single proposition. The parallel network, diagram B. Now, what if we have two switches, P and Q? In diagram B, they are arranged in parallel. This physically represents the logical OR, P or Q. Because the wire splits, the current has two different paths it can take. As long as switch P or switch Q is closed, the circuit is complete. The only way to stop the current is if both switches are open. It is why we use parallel circuit to represent parallel network. The series network on diagram C. Finally, here P and Q are in series, meaning they are on the same line. This is the physical version of the logical and P and Q. For the current to reach terminal 2, it must successfully pass through P and then pass through Q. If even one of them is open, the chain is broken and no current flow. This is a much stricter requirement than the parallel setup. By combining this simple series and parallel pattern, we can map out even the most complex logical formulas into a working network diagram.
I will demonstrate on how to solve a question which is from Final Exam MAT210 July 2025 using law of logic. So, the question given us a logical expression. So, the first question is to draw a network circuit from the above expression, and the second question is simplify the above logical expression using law of logic. First, to draw a network circuit, we need to identify the operator given such as AND or OR operator. AND operator is represented using a series circuit and OR operator is represented using a parallel circuit. Our input ST1 and our output ST2. So first and foremost, we need to identify the operator that connect both of the bracket, which is an OR operator. OR operator is represented using a parallel circuit. So after that, we can solve the first bracket first, which is in the first bracket, we can see that there is two brackets in the inside of the first bracket. In the first bracket, we see that P or R. So P or R is a OR operator which is represented by using an parallel circuit. Outside of the both bracket, we can see that it was AND operator. AND operator is represented using a series circuit. And in the next bracket, we can see that it is not Q or P, which is represented using a parallel circuit. And after that, in the next bracket, we can see that it was S and P, which is a AND operator that represent using a series circuit. Now let's move on to the next question, which is simplify the above logical expression by using law of logic. First, we draw a table, and then in the right side is the reason and the left side is the question. So in this question, you can see there is two P in the first bracket, which is P or R and not Q or P, and both of them has the same logical operator, which is OR. So we can apply a distributive law here. But before we do that, we need to apply a commutative law, which is one of these bracket. So I choose the first bracket and I apply a commutative law. After that, we can see that the P in the first bracket are at the same place. So we can apply a distributive law here. After we apply a distributive law, we can change the position of P in the first bracket to the second bracket. So by doing that, we can easier to simplify it later. So we can do this, we can apply associative law because for operator for P, for the first bracket is OR and the second bracket is also OR. So it will not affect our logical expression. After we apply associative law, which is place the P inside the second bracket, we see that there is two P in the second bracket, and the first P has an AND operator and the second P has an OR operator. We can apply absorption to be only P. Yes, final answer is R and not Q or P.
My name is Muhammad Azmi, and now we are going to solve this logical expression problem from MAT210 February 2025 final exam. Now look at question 1. The question asks us to draw a network circuit for the expression in a bracket P or another bracket of P and Q, and outside bracket Q and Q. Before we start, let's draw our input as T1 and our output as T2. Now looking at the expression, which part do we solve first? Notice that the symbol N and the Q outside the square brackets. This is our MAT operator. Since a conjunction N represents a series connection, we know that entire bracket section must be in a straight line with Q. Next, let's focus on what's inside the square brackets. We see a disjunction or the OR symbol. In a switching network, OR means we need a parallel circuit. So we split our path into two branches. On the top branch, we place switch P by itself. Finally, on the bottom branch, we have not P and Q. Since these are connected by another AND sign, we place not P and Q in series along the bottom parts. Now, look at question 2. We need to simplify this logical expression by using law of logic. Before we start, let's draw a table, equation on the left and result on the right. Notice that we have two P's, one inside the bracket as not P and one outside the bracket as P. Since our sign is OR and the other one is AND, we can expand it using distributive law, and we will get P or not P and P or Q and Q. Next, we see that there's P or not P. The OR symbol will make a statement true if at least one part is true. Since P and not P are almost opposite, one of them must be true. By using inverse law, we can simplify this to a tautology or T, and we will get T and P or Q and Q. Now we have T and P or Q. An AND statement is only true if both statements are true. Since T is always true, the result depends entirely on P or Q. Using identity law, we will eliminate the T or tautology, and we will get P or Q and Q. Finally, notice that we have two Qs, one inside which OR and one outside which AND. We can simplify this using association law, leaving us with Q as our final answer.
Lastly, the conclusion, law of logic helps us simplify complex logical statements and understand their true value. Each law follows specific logical equivalence, and using correct symbol ensure accurate reasoning. This law is essential in problem-solving analysis. Understanding tautology and contradiction help us identify statements that are always true or false.